Good afternoon, everyone, and welcome back to the Bird Monitoring Symposium. For those of you all who weren't there yesterday, I am Tarun Menon, a PhD student at ISC Bangalore, and I will be moderating this final session, final post-lunch session at the symposium. Our first talk is by Deepanjana Saha, who will be telling us, whose talk is titled Aesthetics in the City, and she'll be telling us about the trait bias and observer effects in urban versus rural bird monitoring in the Bangalore region between 2020 to 2024. So over to Deepanjana. Thank you.
Hello everyone, I'm Deepanjana, and today I'll be sharing findings from my work on post-COVID birding in Bangalore. The pandemic disrupted not just the human lives, but also how we engage with the nature. Birding for many became both a coping mechanism and a social outlet. And my talk asked how did the bird watching patterns shift from solitude during lockdowns to socialization after the restrictions eased? And why does it matter for the biodiversity monitoring? So during lockdown, people rediscovered nearby nature. Studies show that the urban green use increased globally. Birding, however, shifted from the solitary walks in 2020 to more collective outings later. These matters because the observer behavior isn't just the background noise. It shapes what birds get reported, where, and how often. As Tulloch and Sabo argue, the accounting for observer effort is crucial for citizen science quality. So my study asked three simple questions. Did group birding rise after COVID, especially in urban versus rural areas? Are weekends driving larger groups? And what do these behavioral shifts mean for the data quality? In short, it's about connecting the social dynamics with the ecological data integrity. I have used over 30,000 eBird checklists from 2020 to 2024 in Bangalore. The key variables include are the number of observers, day of the week, urban versus rural location, and I have used the time series plots, violin plots, kernel density, and the t-test analysis. This builds on the methods from Callaghan et al., who has linked the citizen science patterns to the social behavior. Here is the first result. In urban Bangalore, the average group size per checklist clearly increased after March 2020. In the rural areas, it stayed flat. This suggests that once the restrictions eased, birding in the cities became a social activity again, almost a substitute for other forms of gathering. Rural birding, by contrast, may have always been less group oriented, possibly because of the travel logistics or very fewer clubs. The violin plots show it more clearly. The urban checklist after 2020 not only had large and median group sizes, but also greater variability. In other words, we see both the casual pairs and much bigger walks. In the rural checklist, if you see, the distribution is barely changed. So the social revival of birding looks distinctly urban. On weekends, the group sizes skew heavily to the right, which means larger groups. The t-test confirms this, that is, p is less than 0.0001, so the difference is highly significant. The weekends became the time for community birding, which is often at the urban hotspots. These echoes wider patterns of urban leisure, which clusters around post-pandemic and reported in outdoor recreation studies globally. So, what does this mean? The pros here are more observers often means more detections, especially of rare or inconspicuous birds, which is also given by Miller et al. 2022. The cons include the larger groups tend to bias towards the charismatic or the noisy species, while overlooking quieter and the cryptic ones. The urban hotspots get oversampled and the quieter agro edges may remain neglected. These skews data sets we often treat as neutral. This also tells us that citizen science is not just about ecology, it's about people. The observer dynamics matter: who is watching, in what social setting, and with what motivations. Ignoring these human patterns risks the misinterpreting the biodiversity trends as well. So we will need frameworks that treat the citizen science not just as passive data, but as social ecological knowledge production. Of course, group size isn't a perfect proxy for socialization. For example, two people logging together may not interact the same way as a 20-person bird. I also didn't analyze the species level biases yet, and that's the next step. Using mixed models and the trade data, I'm also interested in pairing the quantitative trends with the ethnographic insights. That is to interview birders about how their motivations have shifted. In this way, we capture not just the patterns but the meanings behind them. Thanks for listening, and I'll stop here and I would love to take your questions. This project is part of a small side project which I had done in during my coursework on how human nature interactions shape the biodiversity knowledge. And yes, the bird data may look objective, but as you saw, the humans behind it also flock together in ways that matter. Thank you.
Hello, Deepanjana. Thank you for being here and answering some questions that our participants might have. While they come in, I just had a small clarification. So, did you
Yeah.
find that there were larger groups post-pandemic compared to pre-pandemic or compared to the pandemic itself?
I mean, on the if you see my fourth graph, you can see that the clearest signs it became a social activity. It came from when I compared the weekdays versus the weekends, right? And the data showed that the people were more likely to go birding in groups, mostly on the weekends, which happens even now, than during the week. But when you compare that in the if you see in the second graph, the violin plots, it showed that after 2020, bird watching has involved more people per outing. So it became increasingly more common. If you see the checklist, it will be common when it comprised to three or more groups together. And in some cases, even larger gatherings, like 10 or more birders together. And this also makes sense because the growing sense of how community is gathering around the city, as well as rather than heading out alone, people usually uh, seem to be joining friends or local for the shared weekend walks.
Right.
This also makes them like feel more connected, also stay outdoors in that way. When very less social interactions, it was very limited, which is because of COVID. And um, and it also suggests that the bird watching for many people, it's not just like a escape into the nature or something, but also a chance to also spend time with other friends.
Correct. No, so my question was, why do you think this started happening more post-COVID? Was this not the case pre-COVID? Didn't like work groups not as big? Were a lot of people not going out together at that time? I'm just trying to understand what changed post-COVID for more people to start going bird watching together, if that's something that you found.
Okay, I mean, like personally, if you ask me, pre-COVID or during the time of COVID, the monotonous nature of just being indoors was maybe a reason to people just venture out suddenly after the COVID. So they just need one reason to, spend, as I said before, to spend time with people and communities outside.
Right.
That could be one of the reasons. This personal reason, although I've just recently been to Bangalore, so I'm not sure how Bangalore was there before pandemic. So I'm not able to
Okay.
comment much about it.
Fair enough, fair enough. I had another question about you mentioned something about the aesthetics of the bird and like, so what happens if you go with a large group, you tend to spot more of the more vocal and more observable birds. Is that something that you also got from your data? Were you able to tell like larger groups had certain species, smaller groups had more rarer species? Did that come out of your data as well?
No, not much, but broadly, I couldn't go deeper into that aspect, which I really wanted to. Maybe I'd need some more data, deep data analysis for that. But answering your question, I would just say, like when you go with people, either let it be experts or even same group of people, when you go with them, you try to capture also the perspective of other person you go from, right? So for example, I see something very peculiar about the sunbirds. The other person might see something very peculiar about some other species. So you tend to learn more in that way, and the traits which I used to capture before may or may not be captured by the other person, and then it tends to become together in the checklist. um but yeah, that aspect, that is another limitation which I found, which I couldn't do. Yeah.
Fair enough, fair enough. Yeah, I guess another suggestion would be to try and look at these patterns in other cities, expand beyond Bangalore, maybe see what's happening in Delhi, Bangalore, Delhi, Bombay,
Metropolitan, yeah.
Metro, yeah, just see
Yeah.
what's happening there. Okay,
Right,
I
yeah.
think so. At this point, we still don't have any questions on Discord, but I'm sure they'll come in through the day. So I'd request you to just
Hmm.
stick around and just
Sure.
check out the thread and see if there are any questions, and please
Yeah, yeah, yeah.
interact with folks there.
Sure, sure.
Thank you, Deepanjana.
Definitely, yeah. Thank you so much.
Okay, so we will now move on to our next talk in this session, which is going to be given by Anshul Gupta, who's going to give us a case study about using passive acoustic monitoring devices in urban landscapes to monitor avian diversity. So over to Anshul.
Hello to one and all present here today. I'm Anshul, and today I'll be talking about the paper I've written that is called A Case Study Using Passive Acoustic Monitoring Devices in a Growing Urban Landscape to Monitor Avian Diversity. With the increase of urbanization around the world, key species in habitats such as grasslands and scrublands are disappearing. About 32% of the world's land area is scrubland and grassland. However, they are still being used for new development projects, and birds playing important roles in the ecosystem such as seed disperser and pollination are affected. Passive acoustic monitoring, also known as PAM, is an observational tool used to study ecology without interfering with the environment. As you can see in the picture, there are two passive acoustic monitoring devices put up on trees or poles. PAM has started to gain interest as a reliable tool for biodiversity monitoring as devices have become more compact and affordable, with software becoming more and more sophisticated. Apart from this, PAM has been shown to perform equally as well as or better than observer-based monitoring. This study assesses whether PAM can be an effective way to monitor biodiversity. Using PAM, a scrub grassland ecosystem was monitored for 5 months for avifauna diversity. Data was collected from dusk to dawn using audio recorders. Data was then run through BirdNet Analyzer under default detectors. Top detections for each species were compared with avian vocalization libraries manually, such as Macauda library and Xenocanta. An implicit goal of the project was to quantify the accuracy of default detectors for species in peninsular India that are poorly studied. As you might know, most of the focus in avian sound recordings are given to countries such as the US, Australia, etc. The findings from such studies are important for conservation efforts by providing credible information to aid major policy changes and can potentially lead the way for cryptic or rare species to be discovered. Coming to the study side, TIFRH, also known as the Tata Institute of Fundamental Research Hyderabad campus, is a 200-acre scrub grassland ecosystem in Telangana, India. The campus shares a border and scrubland habitat with the University of Hyderabad, whose bird diversity has been well documented. Native wildlife from TIFRH campus can be seen on the right. Coming to acoustic sampling, 17 audio mods, you can see one of them in a picture over here on the slide, were set up equally spaced across the site, fastened to trees 2 meters above the ground. They were recording for an average of 25 days in November, December, 25 days in January, February, and 13 days in March from dusk to dawn. So this last part I'll explain in a bit more detail, but essentially here's a diagram that explains it in a more simple terms. So what it says here is the first 20 seconds of each minute were sampled, given that temporal stratification of sampling at shorter timescales is more useful for measures of different types of diversity. So what does this mean? What it's really trying to say is that if you look over here, let's consider these boxes represent 1 hour of time. Now, if you're sampling at shorter timescales, that means you're sampling wherever there's a black line. So you get a pretty good idea of the whole hour. But if you're sampling at, let's just say, first 20 minutes of each hour, which would look like this, then you have no idea what's happening in these 40 minutes of the hour that you're sampling. So studies such as these have proven that sampling like this is better than sampling this way. So here's a map of the points where audio mods were located. This is TIFR campus, and this is a lab actually. So as you can see, all the points are equally spaced. There's a better version of the map over here. So moving to data analysis, using BirdNet Analyzer, data was annotated and later manually validated using Raven Pro. So we put it on Raven Pro. As you can see here, this is the diagram. This is how it looks, the software. And then we compared it with Avian vocalization libraries, like I said before, Macaulay and Zenocanto. The accuracy of BirdNet Analyzer was then quantitatively assessed. So we'll get to that. The settings that were used on BirdNet Analyzer was for confidence 0.75, because anything lower than that might be false positives, that the bird was not there but thinks the bird is there. Location was set to University of Hyderabad because it has been documented. The bird diversity there has been documented more. Location filter threshold, which is the minimum occurrence probability for a species to be included. So let's say that there is a 1% chance that the sandwich tern can be found in Telangana, then it will also include it. We did actually get sandwich tern in the data, which is why I bring it up, but we'll get to that as well. So this is why we put it as 0.01, just to make sure that we get everything possible. Outputs were saved as Raven selection tables, combined to make it easy for further inspection. All the settings were default. So here's the procedure. This is what we followed for reviewing all of the audio. So it was around 5 months of audio. So first thing we did is we check if the bird is reported in Telangana before. Now the sandwich tern has not been reported in Telangana before. So what we did here is we considered it as a misidentification. The reason this probably showed up was because we put the location filter threshold as 0.01. But if the bird has been reported here before, we go ahead with the next step, which is filtering detections from highest to lowest confidence. If it's been seen more than once, if it's been detected more than once by a detector. Now, if there's more than 10 detections, then we just looked at the first 10. If there's less, we selected all of them. Then we assessed presence qualitatively by looking at the spectrogram and listening back to it against spectrograms and audio recordings available on the digital libraries. if we could tell that it was there or it was not there, then we added it to the table. If we were not sure, we asked a few experts and then we added to a table. And then we just did that for the rest of the bird species. This is a screenshot of the actual Excel that we use during processing. So as you can see over here, for example, common house martin, there were 10 of them over here. There were actually a lot more, but I took the first 10, and then we were going through this and try to find out if it's there. And for the common Iola, for example, I found it in the first recording itself, so I didn't check the rest of them. Okay, so this is what I was saying about quantitatively assessing the accuracy of BirdNet Analyzer. We use this formula, so total number of species detected, so number of species detected correctly divided by total number of species detected. So this was 76 divided by 135 into 100 for us. We'll get to that as well. It's going to come in the presentation. Yeah, it's right here. So 135 species detected, 76 found. As you can see here, the percentage accuracy ended up being 56.3%. 21 species out of these 76 were found with a confidence above 0.99. 15 species were found to be migratory. 9 needed expert validation. That means we weren't sure about them. And there were 9 species with confidence above 0.999. That means the detectors are really great for those species. And we also found 3 rare species. So this is part of the table from the paper that shows what species we found, and blue rows are expert validated, pink rows are high confidence. Okay, so I'll quickly talk about the spectrograms here. This is just a comparison for you to have an idea of what we did. So this recording over here is what we found. This is our primary data, and this is a recording from Xenocanto. Same for this. This is our data, this is from Xenocanto. And we compared it, we looked at the spectrograms. As you can see, they're quite similar, Savannah nightjar and common babbler. And we also heard them back to make sure that it is the bird indeed. So this is one of the steps we were doing during the processing. Now, we found a lot of species that were misidentified as well. As you can see here, there were some like dogs or trucks, etc. were mislabeled as birds, and we put that in a table as well. I believe there are 59, and so there were dogs, red-watered lapwings, all sorts of stuff that we found during the processing. So moving to a discussion and conclusion, although we had an accuracy of 56.3%, which is quite low, it is similar to expected values, because when we open Merlin around here, it shows that Sound ID is likely to know 57% of the bird species found here. Cryptic species, we found the Richards pipit in the data through vocalization, and oftentimes people on eBird mislabel it. So that was really interesting. We also found a common babbler that was last seen in the area in 1992 and briefly in 2020. But it's possible that it was something else, some other bird was mimicking the species, so we would require a visual confirmation for that. Savannah nightjar we also found, and since it has a unique vocal signature, we do not think it was misidentified. So, wrapping this up, PAM reduces manual effort compared to point counts. PAM demonstrates potential for monitoring biodiversity in urbanized landscapes. We can help study cryptic and nocturnal species that are usually understudied, and the growing use of PAN can address worldwide data gaps in avian research. I would like to thank all of these people who helped me with Sound ID funding and permits, and these organizations as well. These are the authors. Okay, I'll just wait here for a second. Yeah. And thank you. That is all. We will move to the question and answers now. Okay, just wait a second.
Hi Anshul, thank you for that really fun talk, and lot of data that y'all have analyzed, and I think it's pretty cool. Some really cool species that y'all detected. I mean, it'd be nice if the common babbler is actually there, and it's great that y'all also found the Savannah nightjar vocalizing. I was just also wondering, are y'all planning to kind of also do counts, I mean, visual counts of the species, and then compare some of, uh, say, the species that you all are finding when you all do visual surveys, and then compare that with what you all are finding with the passive acoustic monitoring?
So, in the lab, they are doing point counts. And for example, the common babbler, now the reason we said that we don't think it's there is because the long-tailed shrike could be mimicking the bird. That is one thing, there is a possibility. And we haven't seen the bird around during point counts. So we don't like, and I can give you another example. The black red star, we found this in our data during the winter. And other people in the lab, Harsha, Swati, the co-authors, they have seen it on campus before. So they said that, if you found it, that means it's most likely there. So we did run those comparisons internally to get the final table.
Right. Okay. Sounds cool. And any other interesting, so what were the kind of species that you all were misidentifying? Was there any pattern there?
I would say that there was not a specific pattern. It was just like a few species were constantly misidentified as certain things. So like there was the Eurasian coot that was constant, like a truck horn was like always mislabeled as a Eurasian coot, like every
Oh,
single recording. So there was, I even made
this
a,
was by BirdNet.
yeah.
Oh, okay.
So that was an interesting thing. And of course the lapwings and the Indian technique, these were mislabeled as a lot of them. So I would say if for trends, I would say truck, dog, red word lapwing, and Indian technique. These were the four most common things I would see mislabeled. So for the detectors, the BirdNet default detectors definitely need a lot of work to,
Right.
because red word lapwings and Indian techniques, I feel at least, they're quite like there's enough sound samples of them. So the data, like the analyzers can be trained on to identify that it's that and not a different bird.
Yeah. Interesting. Yeah, so there's a lot of issue with, I guess, ambient sounds in the vicinity that can affect your identifications, right?
Yeah, we were, I mean, it is kind of an urban area. There's like, it's right next to the road and everything. So we knew this when we were going ahead with it, that we would have some sorts of issues with this. But nonetheless, we did find quite a few interesting species, 76 of them, which was
Nice.
a very good highlight of the study.
And would you so how long did you would you say it took, like, because the reason why someone would want to use passive acoustic monitoring is it reduces the amount of manpower, right? So I mean, at this point, of course, the analyzer is not really great, so it requires a lot of manual checking and overrides. So at this point, how much time do you think effort went into kind of making sure that the analyzer was doing a good job, because you had to go and check manually with Zenocanto and the Macaulay library to make sure that what the algorithm was giving you was correct. So is at this point, is it worth the time and effort, or does the analyzer need to get a lot better before it can be used as a substitute for actually people going out and doing the counts?
I would say yes and no. I'll explain my reasons. So we actually collected a lot of data. We collected from over 5 months of data. So having the detector go through a preliminary, like canceling out whatever was noise was really helpful. Although it couldn't identify a lot of things, it did pick up the paddy field pipit, for example, which in point counts, unless you have like an expert, you probably wouldn't be able to identify because that's something that's more distinct vocally than visually. So although it does need a lot of work, it does help if you have a lot, like a really large amount of data that you need to analyze. It is very useful in that way.
Okay, yeah, thank you. Thank you for that answer. I guess that answers a lot of questions that people might have. I'm guessing more questions will come up on Discord. As of now, there aren't any. So I'd request you to just stick around and keep checking the thread to see if there are any questions, and you can potentially continue engaging with the audience. Thank you. Thank you for that talk, Anshul.
Thank you, Tarun.
Okay, so now we will move on to our next talk, which is going to be by Amarjeet Kaur. and she's going to be telling us about common birds in a changing world, the nesting ecology of barn swallows in the Himalayas. Sounds exciting. Over to you, Amarjeet.
Hello everyone, my name is Amarjeet Kaur and today I'm going to talk about a very common bird. So common, but it is so understudied in the Indian landscape. This bird is known as barn swallow, and this is also a species very close to my heart because this species is my PhD work, which is under the supervision of Dr. R. Suresh Kumar from Wildlife Institute of India. Barn swallows scientifically are known as Hirundo rustica. Hirundo rustica or the bird of the country. So these birds are known to nest in the countryside and they build their nest all across the countryside of the western countries or in the northern hemisphere largely. And here the birds migrate long distances and reach in summer to begin their nesting. That's why all across these countries people view these birds as harbinger of spring or harbinger of summer, and they are very closely associated with humans as they build their nest, very mud nest, cup-shaped nest in human artifacts or human structures or man-made structures. And not just now, but also in popular or cultural records and historical records, barn swallows have been very famous in literature all across the European countries and also in Egypt. So, what could be the possible reasons for early these colonization and their global distributions? So, historically, it is thought that historically barn swallows used to nest in caves. But as humans started building their infrastructure or or their structures, these birds began shifting their nesting habit and began to nest inside human structures, and that was also observed in Americas as well as in Amur region, and similarly, it is thought that this happened all across the globe. And because of this, we see the global distribution of barn swallows something like this, where all across the orange shaded area are the breeding distribution of this bird, while and the blue is where these birds spend the winters. They undertake long distance migrations and go down in winters in the southern hemisphere. Because of this, a lot of studies have been carried out on barn swallows, specifically how they expanded their ranges and their adjustment of migration. Also, these birds are aerial insectivores, so they feed near agricultural landscapes where they also nest. So there have been multiple studies on effect of crops or also effect of modern agricultural practices on the nesting of these birds, as well as changing climate and its influence on the migration of these birds. But they are common, yet they are declining. So, barn swallows forms comes under the aerial insectivore guild, where these birds pick insects in the air. And this particular guild, specifically in state of Canada Bird Reports, is mentioned that this guild is the steepest declining guild of compared to all other gills of the bird. And for the past few decades, the birds, specifically barn swallows, are in decline in Europe, North America, as well as in Canada. Canada, that these birds are listed under the as threatened, and they are in decline. The population trend is decreasing. However, India, where these birds are nesting in the Himalayan region, we know that, and they are also occurring throughout the Indian region in winters, but the species, any ecological study is lacking. So to start with, I started understanding what is the breeding extent of barn swallow populations in India, their nesting periodicity, nest survival, and what could be the possible threats to their nests. So going to the Himalayas. So birds are nesting in the Himalayan region, in the hills of the Himalaya, which is very unique than any other nesting sites in the globe. And Himalayan region is occupied by different people of different culture and different religion. Yet they all come together when we talk about barn swallows because there is a similar trend that we see there, a common human commensal and a long distance migrant. So they occur in busiest shops as well as in those shops where they get open access to get in. So if you go to Kashmir, these birds are locally called katij, and they occupy uh, infrastructure, housing infrastructure such as this that is shown in the figure. So prominently present in the village side of the region, and where the people still have those such big windows where these birds get access to enter into the properties and occupy all the rooms or majorly every room of this house. And if we go to the eastern side in Manipur, again these birds are behaving the same way. They are occupying old infrastructure houses, and they are locally called as Samrang. If you come to the central Himalayan region, these birds are known as Ramchiri, Devchiri, Adhanchiri, and so on. And it's all influenced by religion and cultural practices here. And all across these states, these birds are believed to be a symbol of prosperity and goddess Lakshmi. And that's why people are very welcoming towards these birds. And so, looking at the breeding distribution, there was nothing apart from the eBird location. So, utilizing those eBird location, we started on mapping the Bansolo distribution all across the Himalayan states. So, this is a snapshot of one state where we followed the major highways, roads, and routes to different towns, different cities, and different villages, stopping at those major villages and towns and collecting data on the presence of the nest or the absence of the nest, and documenting the nest attributes as type of property in which the nest was located, and also talking with local people on understanding their perception and their knowledge on the species. So if you look at the Himalayan arc, the birds are starting to breed from Kashmir till Sikkim and North Bengal, which is where the breeding distribution just abruptly or suddenly ends. And then we have one distribution in Manipur. So the breeding elevation, nesting peaks at about 1500 meter. But in Manipur, something interesting is happening. So the Manipur is located latitudinally lower than the Himalayan state. This is where the birds are nesting in the center of Manipur, not in the hills, but rather in the valley. Lower latitude could, and therefore low seasonal differences, which could be a reason for abundant food resources throughout the year. That's why the birds here are not migratory in nature, rather, they are resident, which is unlike the case of the birds of the other Himalayan states, which show migrations and which are not at all present in winter months there. And if you look at the distribution of barn swallows by property types, majorly they are nesting in shops, and there is a reason why. So if you look at the segregation across these all the states, we can see that for Jammu, Kashmir, and Manipur, as I told earlier, the birds are preferring old infrastructure, and that's why the nesting is happening in the houses. But in the central Himalayas, they are nesting in shops because the housing infrastructure has been changed and there is no availability of nesting inside those houses. And because of this, barn swallows are also preferring to build their nest inside the property and not outside. And again, because inside the property, they get additional protection because their nest is open from the top. So if it is built outside, there are chances of getting it predated. So if they're building it inside with the additional protection of humans being around, they are protecting their nest. And the case with the nest which are situated outside is not good, and I'll be telling you more on the further slides on the next slides. So if we look at the Uttarakhand state, this is how the breeding distribution looked like throughout our from our survey data, and breeding peaks at 1000 to 2000 meter elevation. Specifically in Uttarakhand, when we overlay these locations with the climatic map of the region, the breeding dominates in regions of tropical weather, which shows mild winter and short warm summer. So this is the kind of climate that these birds are choosing to nest in. And for my nesting ecology, we selected 4 different sites to rural sites, Purola and Kempty, situated at different elevations, different latitudes, Nainital and Bageshwar, comparatively urban sites. And for the sake of this presentation, I'm only going to talk about this Kempty site, where nest was monitored in 3 years for activeness and failness. Observations were made for twice a week, and parallel efforts were also made to ring the adults as well as the juveniles in the village. So this village is situated on the ridge line, and this is how the nests are distributed in the center of the village. And if we look at the seasonality, so the nesting stops as the monsoon peaks up. So this is how the nesting pattern looks like. So they are nesting only in summer months, and when the monsoon arrives, these birds leave the region. And If we look at the different years, 2019, 22, and 23, nesting appears to have shifted earlier. And this is significant. The nest initiation date by year is significant across 3 years. And if we look at the clutch size, as the breeding size progresses, the clutch size declines. And there are two peaks in the clutch size as these birds raise two broods in one breeding season. And if we compare clutch size, hatchling size, and fledgling size for these 3 years, there was not much significant difference. However, there was loss of about 25 to 30% of nests, and which was attributed because of human disturbance and disturbances from other species occurring in the village. So the village is very small, but this village is also disturbed by multiple. This village is a home to multiple human commensal species, and this is also evident from the questionnaire survey that I was carrying out across the state of Uttarakhand, where people reported that 30% of the nests are lost due to house sparrow competition. So, going back to the village, we can see so this is a story of one nest. So, this nest was first occupied by barn swallows. Later on, it was taken over by another commensal species, red-rump swallow. Thereafter, little swift, then house sparrow, and also russet sparrow. So one nest, five competitors. So this nest was outside and it had to face multiple competition in multiple species. And there was also a case where one nest was lost due to the property expansion, and that pair was found to be nesting in the corridors. So, which is again a problem for the barn swallows if they are nesting outside. So, to conclude, nesting of common species is understudied but largely influenced by changing climate and habitat conditions. Specifically, migratory birds, as they are affected by multiple habitats across their migratory range, distributional range, and different climatic uh, shifts. And there is need of undertaking studies on aerial insectivores, given there is a large-scale decline in insect populations across the globe. And there are also site-specific threats. Specifically, for the state of Uttarakhand and also other states in the Himalaya, there is increase in outward migration from the hills, which is leading to abandonment of farms, leading to loss of nest site and reduced food availability. There is change in perception, limiting nest site availability because of tourism influence and other reasons, and also fluctuating climate, pesticide use, and agricultural modifications. I have had the privilege to communicate my research through different platforms to different audiences, and also because of the help of these many people, I could carry out my work across these years through and at multiple sites, and also because of the people of Himalaya, because they led us, the whole research team, to access their properties. And to continue this effort in future, we are also tagging barn swallows starting from the same village, Kempty village, to make aware of the community, to make the community aware of the species, and also to know where these species go in the winter, because that's the most favorite question asked by the local people. And I would like to thank Bird Monitoring Symposium for giving me this opportunity and to letting me speak of barn swallows. Thank you.
Hello, Amarjeet. I hope you're here.
Yes.
Yes.
Hello. Yeah.
Hello, hello. Thank you for that very insightful talk. I too have worked a lot in the Himalayas and have always been super fascinated and extremely curious about how these barn swallows nest in
Yes.
these shops and people's houses. It was always so fascinating. And yeah, I had one initial question is like the cultural symbolism that people have with the barn swallow, is that unique to the barn swallow, or does that also include the red drum swallow? Are people able to tell the difference? And uh,
Very interesting question. Because I was also, when I was serving, I was wanting to ask people because generally what people say ki there is this black colored bird which comes and nests in the house. So some people have this confusion between red drum swallow and barn swallow, but some people, majorly in the remote villages, they know these birds very well and they have different beliefs. So because barn swallow prefer to nest inside, that's why they culturally or they relate more to this. And they know that there is another bird, red drum swallow, which nest outside.
And some birds, some people think barn swallows are lucky for them, while red-rump swallows are not. So that is their perception. But also there is some confusion, because when I ask them when do these birds leave from the breeding grounds, so some people say no, no, they stay throughout the year. And then I tried to tell them whether it is about red-rump swallow that they are talking about. But because barn swallows are nesting inside, and I have observed red-rumped only to nest in the corridors,
Right.
so they are not much into the minds of the people
Yeah,
in the
that's something
Himalayas.
I've noticed as well. They're more in the
Yes,
corridors.
yes.
We have one question from Preeti here. She's asking, is the tolerance and attitude towards the birds in Manipur similar to the rest of the Himalayas?
Oh, yes, very much. So, the unique thing about Manipur, as I was describing in the talk, so Manipur, the birds are resident and they are not migratory in nature. So, because they are resident, people connect with them throughout the year. And they have this name Sambrang for the birds. And specifically in in Manipur, birds are only nesting in the center, in the Imphal Valley, and not in the hills. So when I was serving, I wanted to know what is the limit of these nesting. And people in Imphal Valley told me there is no point of going to the hills because the birds are not there. And when I was serving in the within the Imphal Valley, even the small kids knew about Sambrang or the Bansu, because they're very much like they see the bird every day, almost every day throughout the year. But towards the hill where mostly tribal peoples are staying, they did not even know the bird. I showed the photo; they were not aware. So, but because the birds are only restricted in the center of the Manipur, people have strong associations. And also this is because of the influence of religion. So people generally follow Hindu religion in the Imphal Valley, and they consider Banswalos as a goddess Lakshmi. So that's why it's a similar belief. Generally, what we believe is Northeast India, people have this tendency of hunting wild animals and everything. But for the Banswala, this was a unique case, specifically in the center of the Manipur or Imphal Valley.
We have another question from Muthuswamy, who asks if he had a doubt about the observed clutch size of the barn swallow. What was the clutch size like?
Oh, okay. So generally, it's 4 to 5 uh, chicks in a single clutch, and throughout the breeding season there is about two broods. But if there is a loss of one or two second brood, they try to raise another. But the nesting cease with the onset of monsoon, so that is the constant observation. By end of June, July, they stop nesting, and only the chicks that are there in the nest are there, but no more brood is raised. Yes.
And one last question from Parveen, who asks, have has the ring birds been recaptured from other
Hmm.
places? Do you have any idea of their breeding populations where they are?
From the other places, as in across their range
Yeah,
or
so yeah, where
in
are
my
the
study?
breeding populations that are in Uttarakhand or in the Himalayas? Where are they migrating to? Are they? Do you
Oh,
have any?
okay. So we have ringed the birds throughout the Himalayan region, but we could not recapture them outside the breeding range. We don't know where they're going. But
Right.
within Kempty, within Mussoorie, wherever we have ringed the adults, they are coming back to the same area, rather same nest also. So they're showing high nest site fidelity. And interestingly, for the juveniles, we have not recaptured a single juvenile from the same nesting site. However, only one individual was recaptured, which we ringed in Mussoorie. But after 2 years, we found that same. It was a male. We found that male in Kempty, which is about 12 to 15 kilometer away from Mussoorie. So that is only the dispersal pattern of one juvenile. We're not able to find the other young birds that we ringed. But we also tagged some adults last year, and we captured those birds this year, and we are getting the data out of those geolocator tags
Oh,
that I showed in
lovely.
my last presentation. So we might be able to understand. So we got about 3 tags back. So we'll
Oh,
be able to say
oh.
something about the migration.
It's excited to hear about that whenever you analyze it.
Yes.
Thank you, Amarjeet, for that lovely talk.
Thank
We now have
you.
to move on. Thank you again.
Okay. Thank you. Thank you.
Our next speaker is going to be Paul, and he's going to tell us about the long-term trends of birds in Kadamakudy wetland in Kerala. This is our last talk for today, so over to you, Paul, and best of luck.
In 2011, farmers and activists of the Kerala Shastra Sahitya Parishad from Varapura approached the Kochi Natural History Society asking for a solution to a problem they were facing. Grey-headed swamp hen, known as purple mooner at the time, were harming the Pokali paddy cultivation by feeding on the seedlings, nesting in between the clumps of rice, or trampling them. CNHS conducted a study to understand the bird abundance in the region with a focus on the swamp hen. Thus began the regular monitoring of birds in the Kadamakudy Vadapura wetlands by the members of CNHS as well as birders in general. Today, this small patch of wetland among a larger water body is a haven for both birds and bird watchers. Hi, my name is Paul, and today I'll be presenting about the long-term trends of birds in the Kadamakudy wetland, a wetland that is found in the Ernakulam district of Kerala. I'll be showcasing the insights that I gained after crunching the numbers from nearly 1.5 decades of citizen science data, specifically eBird. Kadamakudy wetland is part of the longest lake in India, the Vembanad Lake, which is also the largest lake in Kerala, and it is designated as a Ramsar site. Kadamakudy wetlands, despite being a small portion of this hydrological landscape composed of rivers, lakes, marshes, and Pokali rice fields, hosts an amazing variety of birds and other life forms, especially during the migratory seasons. The study region is located somewhat near the coastal regions of central Kerala. The green dots in the map represents the checklists that have been submitted from this region, and as you can see, it is clustered mostly near the Valia Kadamakudy region. As you can see, the number of checklists between 2011 and 2013 were very sparse, and from 2014 it started picking up, and the highest number of checklists was from 2018. Likely as a result of the sighting of the ruddy shell duck, there seems to have been a dip during the COVID period. In terms of bunds, the most active period was during the border years, and the least active period was from April to July when it was mostly monsoon. Most checklists were within the duration of 1 hour, making it useful for analysis, and most checklists were within the radius of 2 kilometers of distance traveled. In terms of protocol, the most common protocol was traveling checklist, followed by stationary checklists, which was around 25% of all the checklists. 237, that's the number of species that have been found in the region between 2011 and 2025, which is a staggering amount considering the size of this place. 53 rare species were found in this region. Rare species is defined as those species that are found in less than or equal to 33.33% of the study duration, that is less than or equal to 2 years out of the 14 or 15 years. 2018 saw the highest number of rare species, that is 16, followed by 2017 and 2016 with the 10 each, and then by 2019 with 7 species. This included the forest blacktail, the brown-backed needletail, the Caspian plover, dusky warbler, among many other species. Majority of the 237 species, that is 186 species, are migratory, such as the gull-billed tern or the Pacific golden plover. 51 species are residents, such as the medium egret, the Brahmani kite, and the Ashiprinia. One of the things that I looked into was how I could classify the birds based on their migratory patterns. I came to the conclusion that classifying them based on specific seasons is not very useful for the following reasons. One, most of Kerala don't have a clear cool/cold winter season, and in fact it's more like summer in Kerala during the end of the Gregorian year or the beginning of the year. It would be confusing and simply wrong to use the word winter migrant to refer to species coming to Kerala at a hot period of time, especially to places like Kadamakudy, which could be really hot at the time. 2. The winter/spring/summer/autumn classification is temperate country bias classification. It would make sense to use it in places like northern and central parts of the country, but not the deep southern regions, especially the coastal regions. It ignores India's variability in climate and hence is incorrect when applied to regions like Kerala. 3. While wet and dry season classification is a good alternative, as used in the Kerala Bird Atlas, it cannot be applied year-round as there is a short dry season in between the two monsoons, southwest and northeast monsoons, during which the species may stay back. So classifying them based on wet and dry season may leave out most of the species who are not migrating simply based on humidity or rainfall or warmth. To capture the complexity in bird migration, I have developed an alternate system/schema for classification. I've only used data falling within the years 2014 to 2024, that's 11 years, as the rest had sparse or incomplete data. There are four major components to the classification. One, regularity of migration. It tells how regularly or frequently the bird migrates to a certain location. If recorded less than or equal to 20% of the years, that's less than or equal to 2 years in this case, they were considered vagrants. If recorded in greater than 20% but less than 70%, that's greater than or equal to 3 and less than or equal to 7 years, they consider irregular migrants. If recorded in more than 70% of years, they consider regular migrants. 2. Year split. Instead of seasons, I've coined two terms. A. The term border year migrants to refer to species who are found in significant numbers during October, November, December, January, February, and March, the months bordering a year. This roughly matches winter migrants and sometimes autumn/spring migrants too. B. The term mid-year migrants to refer to species who are found in significant numbers during April, May, June, July, August, and September, the months in the middle of a year. This roughly matches summer migrants and sometimes autumn/spring migrants too. Combining the regularity of migration and year split components, we get 7 main categories. That's regular resident, irregular resident, regular border year migrant, irregular border year migrant, regular mid-year migrant, irregular mid-year migrant, and vagrant. There were 32 species who did not fall into any of these categories. So a combination of these categories were used to describe their migratory patterns, as it was not so clear cut, such as irregular border year migrant/mid-year migrant, regular resident/regular mid-year migrant. This classification is primarily based on the proportion of mean relative abundance in the border years combined and the proportion of mean relative abundance in the middle years combined, and other factors such as number of years recorded and number of middle year months. Two other components make up the flavor of migration that complements the migratory status detail and give a more in-depth understanding of the migration for individual species. These are 3. Passage or preference. Site preference or site fidelity is an indicator that the species specifically seeks out the same location, that is Kadamakudy Vadapura, for wintering or summering. This is very important as it will let you know for which species this particular location is important. Passage shows that the species utilizes the site for just refueling and not for extended stay. 4. Overstay indicates if the species classified as a border year migrant also overstays in mid-year to a lesser extent or vice versa. There are two variants of overstay. Adjacent overstay, where the species is only found in adjacent months. For example, if a species is found in January, February, March, all 3 border year months, but also in April, a mid-year month, the overstay or overspill of the stay is adjacent to the normal migratory year, giving an indication that they are strongly border year migrants and as a minor overstay. On the other hand, if a border year migrant is found in January, February, March, and also in April, June, and September to a lesser extent, their pattern is dispersed overstay, making it a bit more difficult to explain their migratory patterns. It's more erratic. There can also be no overstay. Combining these two components of the flavor of migration, we get several combinations such as passage with no overstay or adjacent overstay in mid-year and dispersed overstay in border year. Two major assessments of the long-term trends from the study were monthly and yearly relative abundance trends. The relative abundance were calculated using a Poisson generalized linear model using duration and effort distance from the checklist data. Now let's look at the long-term trends for some of the species. Blight-streaked warbler was found to be a regular border year migrant who shows site preference with adjacent overstay. This is clear from their monthly abundance chart. Over the years, they have increased in their abundance in the region. Osprey is another regular border year migrant, but they show site preference with dispersed overstay. Although they peaked in 2021, their recent abundances have been almost consistently lower than their pre-2019 abundances. Pheasant-tailed jacana is another regular border year migrant who shows site preference with dispersed overstay. Their abundances have increased considerably since 2021. The Brahmani kite is a regular resident whose abundances have almost steadily increased over time, and this is true for black kites too. This may be attributed to the increased fisheries activities in the region. Crater cuckoo is another regular resident who has shown increase in their abundances over time. Black-tailed godwit is a regular border year migrant who shows site preference with dispersed overstay. Their abundances have increased nearly exponentially from 2017 to 21 and then crashed in 2022, which is of concern since this is a near threatened species with the SOIB high priority status. Curlew sandpiper is a regular mid-year migrant who shows site preference with dispersed overstay. Their IUCN status is vulnerable and they are a high priority species according to SOIB. While their abundances increased till 2019 in the Kadamakudy region, it has gone down since then. Pied kingfisher, who has been a resident for a long time, has not been sighted in 2024 and has been on the decline ever since data was available. This might indicate a deterioration of the habitat and water quality. Another regular resident that has gone missing is the ashy wood swallow, who has declined in their abundances. Now we'll have a look at the species who is primarily responsible for the origin of this project. Created swampin could be a regular resident in the region or could be a regular border area migrant, or more likely there could be populations which are regular resident and some populations which are regular border area migrants. Their yearly trends are not that clear either, and their abundances seems to be cyclic with peaks in 2015 and 2022. Other things that were looked into during the study was the comparative abundance of species within different groups, such as the waders, who are species belonging to the order Charatriforms. Among the 56 species of waders, Tibetan sand plover, whiskered tern, common red shank, and Pacific golden plover were the most abundant. Among the migratory species, the most abundant were the lesser whistling duck, Tibetan sand plover, Pacific golden plover, whiskered tern, black-headed ibis, and barn swallow. It is clear from this study that there is a large number of birds who depend on this wetland for their survival. This includes 51 resident species and 47 regular migratory species, and including irregular migratory species, we have 93 species who prefer this specific site. 18 globally threatened and 41 SOIB high priority species have been found here. The monitoring needs to continue, whether it be through organized annual efforts or through informal birding trips. I would like to thank all the 411 eBird accounts that contributed to the data. I would like to thank Vishnupriyan Karta and Dilip KG for inviting me to do this analysis. I also thank Praveen J and Ashwin Viswanathan for helping me out with some suggestions.
Hello, Paul. Paul. Hello, Paul. Can you hear me?
Yeah.
Thank you for that really interesting talk and some really new kinds of analysis that is new for a lot of us here at the conference. So I think the first question that has come up is from Preeti, who asks that this is quite a detailed classification scheme, and where can one read about these, and how do you suggest people use it?
So I'm yet to write the documentation for it, but the script that is used for the analysis as well as the documentation, including the schema for classification, will be available soon. And my plan is to try this and transfer this to different regions of India. Start with other regions in Kerala and then move on to other regions. So this is based on a thresholding. Like I study 25% of the species within that consortium of 237 species, and try to figure out if there are any patterns like irregular migration or regular migration, and then use that as a threshold for creating those proportions. I mean, using that proportion to classify.
Yeah. Right. No, so how would you what would you suggest to someone else who'd want to use this? What are the contexts that would be best to use? Of course, somewhere like Kerala, extremely tropical area, I think it makes sense. So what are your suggestions? I think that's what Preeti wanted as well.
Sorry, could you repeat what is?
So I was just saying that Preeti was also asking, how would you suggest people use this? So this classification scheme makes a lot of sense for someone in Kerala, in the more tropical parts of the country. So what would you suggest for someone who would like to use your scheme?
So look at the species themselves and identify the species who have like there are species who are purely found in what you call as winter, and use that as a threshold for marking the proportion. Like instead of so essentially, if you're in the northern temperate regions, what the border migrant would refer to is is essentially swappable with winter migrants, but towards the equator, you don't have that kind of seasonal changes. Right, in some of them, it's nearly warm throughout the regions, and it would be useless to use terms like autumn, spring, and winter, and all of this. So it has to be specific to the region and specific to the the community of birds which arrive to that location. I hope that answers.
Yeah, and Preeti has a follow-up, which was a question even I had, was the 2021 number for Godwit seems quite unusually high, the black-tailed Godwit. And so I had a similar question about like how was the abundance calculated? Is that not an anomaly? Have you yeah, so can you tell us a little more about what was with that sudden increase and then sudden decline? Any insight over there?
I think it reflects the nearly true estimate of the abundance, because I did a lot of pre-processing, and which I have not discussed in this presentation, because a lot of filtering done to reduce the effects of observer bias and all the distance effort what do you call the impact of effort on the abundance estimate. And even I had actually did three scenarios. One was the Poisson distribution with 1 kilometer in less than 1 hour of. Then I did it with 3 hours and I think 2 kilometers to increase the number of usable data. Then I also checked the mean, just the mean relative abundance calculated from the mean observation count, right? So all of them had the similar kind of trend in for most of the species. So I feel that this is kind of accurate. Maybe the black-tailed godwit is moving to a different location that is adjacent to the Kadamakudy region. That could be a reasonable explanation for this.
Fair, possible. Ashwin has one comment. Excellent talk and analysis, Paul. Worrying trends for species like the black-tailed godwit and the pied kingfisher. Hope the methods and results are published soon. I don't think it's a question, but just a comment. Yeah.
Yeah, definitely. We had this discussion with Ashwin, so I'll make it public. I just need some time. I mean, this is not my actual work. This is something that I did on the site since CNHS requested, and I'm actually now hooked onto this. I'll try to make it. I'll take it further. Right.
I had one last question. I was curious, are the swampland actually affecting rice paddy? Is that what was the finding of the original study?
So in 2011, Dileep from CNHS, he had published a report. They did a survey at the time, and they said that it's because of them not planting rice or something, that there is an invasion of things like Iconia and African weed that is actually helping them. Where there is more Iconia, or now it's called Ponditaria. There are more swamplands coming in, and that could be a possible explanation. And he has suggested some methods to alleviate the problems. The trends are not really clear, but I don't think that swampland is going to affect a large. It's probably not the impact would not be that large to the. There are a lot of other species who also are found in the location, and they are also they also eat grains stuff. So.
Great.
All right.
Okay, I think that's all the time we have. Thank you, Paul, for that really insightful talk, and hope to see you again next year.
Yeah, definitely.
Okay, so that brings us to an end of the symposium, and it was a lovely set of talks, and you all can continue interacting with the speakers and interacting on Discord. And I will now pass it on to Parveen, who's going to give us some closing remarks and a summary of what all we learned at the conference. Over to you, Parveen.
Thank you, Tarun, and thank you all the speakers in this short talk session. It was indeed a really engaging one. It has been great 2 days, and I take this opportunity on behalf of the organizing committee to conclude the symposium. We would like to thank everyone who joined this and made the symposium so engaging and lively. Special thank to our keynote speaker, Dr. Jaipal, our invited speakers and our panelists, Dr. Dhananjay Mohan, Sahana, Praveen, and Subhadra, for bringing such a thoughtful insights and sparking great conversations today morning. And of course, to all the participants, your questions, ideas, and enthusiasm kept the energy going throughout. We are really grateful to all the volunteers who helped things run so smoothly on Discord. And a special shout out to Amit and Tamizan for handling all the technical aspects and making virtual symposiums seamless. To all the participants, hope you get a chance to catch up on all the presentations. If you have not had till now, the Discord server will be open and the symposium channels will be active for the next few weeks. So do take advantage of the fact that this platform allows interaction over time. And you're welcome to ask questions over the next few days. And we request you once again to fill out all the feedback form before you log off for the day. And so this was the theme for this year. And let's see what the symposium has for the coming next year. And we cannot wait to see you all again with even bigger community and more exciting sessions. So I would just like to thank you again, everyone, and like to conclude this symposium right now. We can still get back on Discord and continue interacting over there. And please do fill up the feedback form which is there on the channel. Thank you so much.